Hello guys, welcome back to Root and Route. Today we are continuing with the REST programming and we'll be adding more functions to our web application vulnerability scanner. On last video we did automate functions for cross-site scripting, both reflected and stored cross-site scripting. Today we are going to automate SQL injection and command injection. So let's dive into the demo now. So before going deeper into what we are going to automate, you should know what SQL injection is. If you ask me a formal definition, this could be considered as a formal definition for this. It's a type of vulnerability where an attacker injects malicious SQL code into a query, and this happens when an application takes user input and includes it in a database query without properly sanitizing or filtering it first. If you are getting confused on, if you are hearing this first time and if you are getting confused, I will show how exactly it happens. So instead of providing standard data where it is expecting a normal data, as an attacker perspective, attacker could inject SQL injection characters, and that could allow the attacker to run arbitrary SQL commands on the database. So how it works, let me show you a demo. Let us open our suite. We already have a basic framework that we developed on the last video. So we will be adding some more functions to the same framework. So if you missed out the last one, I highly recommend you to go and visit that one and just go through how we did automate the XSS scanner. So here we are going to do the same thing for SQL injection and command injection, but the type of vulnerability is different compared to XSS and compared to the XSS that we did on last video. So let me show what it is and how it works in theory. So localhost, I'm just making the interceptor off. Here we are using this intercepting tool to analyze the application and find out required parameters to help us automating easily. So I'm just, for the training demo, I'm just making it low. So now we go to SQL injection, and here it is expecting maybe user ID. When we give the user ID, the proper user ID, it says it returns the first name and last name of the user ID. And just suppose if I give something that doesn't exist, it's not returning anything. So that's a function, intended function for this field. So here is the suppose if the user, the developer doesn't care about the input validation, here we can inject our SQL injection characters. So the SQL injection character, the very famous one is this one, single quote or one or two, any true condition is fine here, and we just say, and this symbol, the hash symbol or a double hyphen is all depends on what kind of DB that you are using in the backend. So there are a lot of stuff you should learn before doing SQL injection. Basically you should know how SQL queries work. Other than that, if you do SQL injection without knowing how queries work, it is just, yeah, people are doing like that, but I'm just saying, if you want to do, see here, if you check, you can see instead of the one, we injected single quote or 1 equal to 1. This one, this was our injected characters, and it returned all the DB tables, all the tables for us, not only the one that needs to be it should be the expected result was like this if it was a proper input, but for the injected input it returned every rows. So now we and if you check the source code of this one, we can see what happens here. The developer is using an inline query, and the inline query just blindly adding the ID parameter that is from the request. He is directly taking it from the request and adding directly that to the inline query. This query is this is the reason that we are getting this the characters got injected and it returned all the rows. So if you see the backend, I already connected to the DB, and let me show how it works here. So we have two tables here, and this was a table that was working when we were trying to do the SQL injection. And on a normal query, select just start from users. No. Select start from users. This will return all the columns. For the sake of testing this one, I think it was returning first name and last name. First name and surname, maybe the first name and last name. Yeah. So I'm just taking these two columns here. First name and last name. So these were the columns it was returning when we after injection, but the actual query that was supposed to be running where maybe I think the user ID, right? User, or there's a column name for that, user underscore ID equal to 1. This was the first result that when we put 1 here. Actually, this is, you're seeing this one, and this was the query that was running behind the scene. And the injected code, what happens after we injecting something? So here we are blindly, the application was using accepting the user input, so it comes here, or 1 equal to 1, and see here there's a code already here, and you can see that in the source code. So this single code is getting filled up like this here, and what does it mean is, like, suppose if there is no 1 equal to 1 or 1 equal to 1 is not there, just see this doesn't return anything. That means the where condition returned a false, but when we add a true condition to that, it is like a true or false condition that always return true. So that's what happened behind the scene here. If you do this, it returns everything from the table, because this is just like saying where user ID equal to a null value or a user ID is equal to a true condition. So the where condition always returns true, and on result of that we get all the columns, all the rows from the table. That's what happened here, the same thing. So that's how SQL injection works, and if you have more doubts on that, please refer our top 10 guide. It's not that much complicated, but if you are not familiar with SQL, then it will be really no meaning of continuing with this one. So be familiar with SQL and how it works, tables, database, and basic data queries. You should be familiar with that. So let us now, our aim is to automate this same stuff. So what we can do is, for automating this one, now you can try with something else, like this is another possibility that it couldn't, even our query, our injected characters were not properly, we didn't form it properly, we missed some parts. So but this that made this one return some error. So we could say possibility of SQL injection where if you see these kind of errors, that also one of the methods that you can try to find and automate. When you're trying to automate it, you can just use this logic also, and yeah, of course the other logic, like the other best way is that it's always good to set up a baseline for your response. As an example here, when we enter normally, it returns one response and it returns something entirely different for this one. Maybe a hash. See, this is completely different from the other one. So you can compare these response and you can say potentially this application is vulnerable for SQL injection. So we will be following the same thing. We put a baseline first, then we go to the other part. So before doing automation, we have to analyze the application, how it works, and what are the parameters that is passing, and what is a get request or post request, and the parameters to submit. All those things we have to find out. And here we can say it's a get request, and this is the path, and ID is the query string, and we have to pass the submit also as a parameter. So if you have these, we can test this. So let us start coding our part. We already have this one, and it's a query string, so I am going to use this one. I'm just copy paste to save time, verify. I'm going to say SQLi. So target URL instead of XSS, I'm going to say SQLi payload, and then we found it as ID as the parameter, and it is going to be SQLi payload, and here SQLi test response. Instead of so we had to set a baseline for this one. So we need two request and response. So I'm copying this one first. I'm going to say baseline query string, and the baseline I'm going to say baseline is just a normal one. So the baseline query string I just put as 1, and baseline query response, I'm saying the response for the baseline is with this baseline query, and we are sending and we are getting the baseline response. Yeah, we got the baseline query response, and we have to use this. So now we have the baseline text response text with us. So next thing we had to do is, I can say malicious query string, and here is going to be SQL injection, and let us give that as a payload, actual SQL injection payload from where it is going to call. We are supplying the payload from the main function. So the test response for this one, we forgot one more thing. We should be adding, I think, this parameter also. So I'm going to do that now. Submit, and the string is also same. We'll do the same here. instead of the baseline, I'm just saying this one. So now the malicious query string is here, and for testing this one, we are passing this malicious query here. And yeah, if okay, we don't need this one. We can say if this response is not equal to the baseline query, and we can for a better confirmation, we can say whether the SQL injected response text, we had to get let SQLi response. This one is confusing. SQLi test response, and this is text. Now we are comparing this text with the baseline query text. And if the SQL injection query contains from here, when we are testing with this one, we got one error. So we can say just take this part, MySQLi error. So I'm saying this one, if this text has this exception message, then there is a high chance that we got potential SQL injection found with payload, and this one is SQLi payload, and target URL is same. And here we can say SQL injection not found with SQLi. So I'm just going through this faster because we already explained how these things work on the other video. So it is, if you're seeing this first time, it may be confusing for you, but if you already saw this, then the previous video, then it will be really easy for you to follow. I think this one is here. It should be okay. Now we have to, okay, I'm just commenting these parts. So before doing the async call, the real async call, I'm going to test it. So here I'm going to say let SQLi URL equal to, what was the URL here? Yeah, this is the base URL. And let SQLi payload equal to this one. We can say, yeah, it should be single quote or a true condition, then some symbol that will help us to comment out all the query after that. So this could be a payload, and let us call this let SQLi res to verify SQL injection query with the SQLi parameter and this one, and yeah, I think we can print this one. Once both functions are ready, we will add that to the Tokio join and we will run it parallelly. So let us try this one now. Better, yeah, I will use this same terminal here itself. Go run if it doesn't have any syntax issues. So yeah, see, it says potential SQLi found with the payload this and in URL this one. So it says so, but either we can test it by changing this one to high and test it. See, on the high, actually the source code, it has a better source code, so it filters out this payload and is saying it's not found. And another way to confirm this one is just try to pass instead of this one, just pass 1. So it should be the same, the response should be same for both baseline and the SQL injection. See, this works fine. So this is one of the ways to automate stuff, and this is not the ultimate ways, because it is not recommended to test with only one payload, because the more better payloads, the more better result. So the next level of this application is you have to make it in a way that it accepts more payloads and it runs parallelly. So this is a part of SQL injection, and we did automate that, and we now know it is working fine. So let us move to the next one, command injection. So what is command injection? It is another injection vulnerability, but instead of running commands on the database, it runs commands on the host operating system itself. What does it mean? That so the same application, if you consider this another area on the application is called command injection, and here it normally accepts a parameter, and that's accepting an IP and just trying to ping to the IP. So and if you check the parameters here, just for our reference, it's a post request and it has an IP as a form parameter and a submit. So if you for automation we need these two, and what happened behind the scene is it just try to ping to the IP that we gave, and for bypassing this you just say I'm just separating the command, multiple commands using a semicolon, and I'm just giving my second command. So now it did ping plus it gave me the result of the second command. This is more vulnerable, more dangerous when the application tries to do this kind of stuff, allows to do this kind of stuff. See, it just dumped all the etc password file, so this is more dangerous. So how can we automate this? So this could be automated the same way like the other one, but there is no need of checking baseline here. Here what you have to check is you should know what the result of every command that you are supplying. If you are going to do this one, you should know the return result must have some expected string that is there. So the best way to test this one is using a sleep command. As an example, if I put sleep 3 here, so you can see it is taking 3 seconds to get the response, and of course there is no other extra stuff came back here. So for testing and confirmation, we can use the same sleep command in our program logic. So next we are going to do that. For that, let's go back to our implementation, and since this is going to be a post, I'm going to copy this part and let us paste it here, and same verify CMD injection, and it is CMDi payload, but the parameters are different as per the analysis that we did. We need IP, and IP is the vulnerable parameter, so we have to supply our payload to this parameter, and it is submit. And here you can say submit, the same thing. And here it is IP, and it's going to be CMDi payload. It's just rename this CMDi params, and I'm just using these things, and we don't need this one. Only 2 parameters are there. Just take off this code, and now what we have to do is we know already we are going to use the sleep command. So what we can do is we have to check the time. Let's say start time. There's a package in Rust. I think it's instant. No, sorry, always forget this operator. Now before the sending the did I copy the wrong one? It should have been the post. Yeah, it was the post. I don't know what happened here. This is no, I think I'm doing something wrong. I did copy something wrong. Anyway, I'm just keeping it here and just removing no, it is something wrong happened. Just pasting here. There is a problem of copy pasting. We have to take the CMD parameters and just checking the time before the post, and just say this is CMDi test response, and here we don't need to instead of access parameters, we have to do the CMDi params and send it. And here what you have to do is we don't need to compare anything. We just say we already posted it, so after posting we have to find out the elapsed time. Just say elapsed just a time something equal to yeah, there's a function called start.elapse because we already have the start here. So now we have the elapsed time, and we just need to check if the elapsed time, not milliseconds, we going to say dot as seconds. Yeah, as seconds is not 5. We will be testing with 3. That will be a decent test. If the time is going to take for the post, if the response time is going to be greater than or equal to 3, that means our sleep function is working behind the scene. So then we can say cmd potential command injection found with payload. This is cmdi payload, and here say no command injection found with payload and this URL, and this is going to be cmd again, cmdi payload. Hopefully this will work. Let us verify. So go back to the main and say what was the parameter. The base URL for this one is this one. So I'm saying let cmdi URL equal to this, and cmdi payload equal to, I can say the same payload that we tried, 0.1 and a semicolon, then sleep, then just says 3 seconds, and the result is verify cmd, this one, and wait. Yeah, try this. Let us run both. Cargo run, and here it should return the result. See, this one is taking time, so hopefully that means it worked. The injection spelling is wrong, but we got what we wanted. We tested with 3 seconds sleep, and it is taking 3 seconds sleep, and it is working fine. So now you know how to automate the stuff. Now we added 2 more functions to our web application vulnerability scanner, and this is not a production ready vulnerability scanner. It has to do a lot of more work. You have to make it more effective async operated scanner. So for that, what I can do is so here was the place we were trying, and I'm saying here we are going to do it in parallelly, concurrently, using SQLi result and cmdi result. So what we are going to do here is verify SQLi and SQLi URL, SQLi payload, and verify cmdi URL, cmdi payload. Here there will be another issue. It's not an issue actually, but it's a problem of our design. The second task that is going to take it's going to take 3 seconds. So that is going to affect the entire concurrency, because that's how the join macro works. I'll show you that. We don't need these 2 lines. Now we are going to do this concurrently, so let us try to run it with Tokio join macro to make it concurrent. Just see it's logging to DBWA. The previous result, when we were testing, we got the first one, SQL injection not found, as a faster response because we were running sequentially. But now you see, just because the second one was taking a bit more time, it affected the entire asynchronous operation. So yeah, that's a problem of the design. Now it's working fine, is running concurrently, but you have to do more effective concurrency using Tokio, not like this one. We may need to redesign the concurrent way of not blocking, return the first result like SQL injection not found immediately once it's getting the response. Don't need to wait for the second one, I mean the sleeping operation. At present actually it is returning after completing both, because that's how we just use the join macro. So the main thing was to add more functions on this one and just to try more automation using Rust. Hope you understood this one. You did understand how SQL injection and command injection works and how can we automate stuff. So we will be digging deeper into the async operations. I will be considering that async operation as a separate exclusive video, because that needs more explanation than just using a runtime like this and just using a join macro. It's more than that. So we'll be using more Tokio operations on upcoming videos, especially when we are trying to do network operations. We need that more. So that's all for this video. See you soon with another one.